So for our first speakers, I would like to introduce you to Sistu. Sreedhar is the Vice President of AI Offers at Schneider Electric. He leads a team focusing on applying AI to address important challenges in energy management and industrial automation domains. His interests include applications and operationalization of AI at scale in cloud and edge environments. Prior to Schneider, he was the director of product management at Dassault Systems, working on SAS applications for 3D design and product development. Sreedhar has an undergraduate degree in mechanical engineering, a master of technology in statistical and operations research from the Indian Statistical Institute, and an MBA from Fuqua School of Business at Duke University. So please, everyone, welcome Sreedhar.
Okay, all right. Okay. Hello, everyone. That was a pretty long introduction that I never imagined when I wrote my bio. First of all, very happy to be here on behalf of Schneider Electric and talk a little bit about AI, that how we see AI and the application of AI, from a Schneider perspective. I have just a few slides to talk about Schneider for those of you who may not be aware, and I would not be surprised if many of you are not. But I won't bore you with all the details of the company, for my entire session. So, Schneider Electric is, our purpose is really focused on, sustainability. We are the, one of the largest energy management and sustainability companies. It's all about electricity, optimizing the use of electricity. We don't produce electricity, we don't make equipment that creates electricity, but we do everything to distribute and use it efficiently. And that applies to both facilities such as commercial buildings, something like this one, and manufacturing plants, and even critical infrastructure facilities such as data centers, which is where we focus a lot on these days. As a company, quick summary on some statistics. So, we're about 29 billion euros in revenue last year. These are the officially released ones. We have global presence. We are a company that has a multi-hub strategy. So we are based in Boston. We actually have 3 major facilities in Boston. There is in downtown. There is an R&D center in Andover. And we also have a manufacturing plant in Foxborough for, process controls. And then we have a hub in Paris, and we have a hub in Hong Kong, in fact, where our CEO is based out of. And we have a new hub coming up in India, given the prevalence of, the market there. It's a huge market for us. And we have about 128,000 employees across the globe. Okay, I'll move into the topic really, how AI plays into, Schneider. First of all, when you think about energy, we see electricity as the most effective way to use and consume energy. Because electricity, is much more bendable than any other form of electricity. Because once it comes, we can control it digitally. So we believe in the growing electrification will be a transformative thing to optimize the consumption of energy. So we see this, growing. There are obviously growing trends across the globe in improving infrastructure. Definitely a lot going on in US and in Europe, due to some of the recent investments in infrastructure. And now all these equipment that are assets that are managing electricity, all of these are connected assets that we have. And we have invested heavily in IoT platforms in over the years, and they generate data. And we see AI as the next big transformative technology to optimize using energy in the form of electricity. So to do this, we have a strategy around applying AI at scale That is a global function at Schneider, and we apply it across domains, which is in energy management and industrial automation and sustainability. So first of all, it is about building AI. We have pockets of innovation, and the purpose really is to scale. How to make things at scale. And when I talk about AI, sometimes it is not that the problems are very novel or new, something that is super exciting, but it is really operationalizing at scale, and the problems are enormous. And then delivering, because we have to deliver these solutions, these AI-based solutions, across the globe, and in extremely difficult operating conditions. Not all of our customers are in urban areas. They are in deserts. They are far away. They are disconnected, and we want to provide solutions to them. And then doing things at scale, especially when we are talking about delivering AI on assets in the field, and we are talking about millions of devices, critical infrastructure equipment that we would like to manage. So it is, I think we've got a bit of a change in the slides. I'll talk through them. We have a number of customers who currently use our AI technologies. And I will talk to you about, we've been doing this, but now we are really trying to scale up. One particular customer I want to talk about is, Lidl, where it is a complex problem of both machine learning, particularly forecasting, and then optimization. Because what we see is in the area of energy, there is a trend towards people who are not just consumers, but also providers. They are producing electricity. Large buildings throughout the world now produce electricity using solar panels. Now, how to effectively share that energy with the grid is a complex problem, because there is the power quality. Not all the power is same. The one that comes from photovoltaic cells, may not have the right level of frequency, and it has to be inverted and whatnot. And then there is growing demand with respect to the electric vehicles that are getting into buildings. So, but then electric vehicles can be charged in an optimal way. Not everything has to be charged at the same rate. I can distribute charging so that I can optimize the usage of electricity. So what we have here is a control of energy on site, using both machine learning for forecasting primarily, and then a lot of optimization to use the distributed resources. So when do I, charge my battery? Either using grid or using, the solar panels. And when do I use the generator? So it's an interesting problem. It's not a pure machine learning problem. It's machine learning and optimization together. Now, while we have a few customers, and I did not intend to talk through all of them, wanted to give you a scale in the limited time that I have. What I do want to talk about is the broad classes of problems that we are dealing with. And I know a lot of students here are interested in the use cases and the type of things that we want to do. So I'm going to spend a little bit of time here. So these are some of the key use cases or categories of problems that we deal with. First and foremost, forecasting. And forecasting is at the heart of lots of problems that we solve. Because when you do predictive control, you have to predict things. And we are all about controlling things, whether it is HVAC system to optimize the comfort in the building, or controlling things in a manufacturing plant. So forecasting plays a super critical role. For example, one of the things that we do today is building energy forecasting. So if you have a building based on some basic parameters that we have, not necessarily knowing everything about the building, but the general size and historical data, we can predict with reasonable accuracy the energy consumption that allows us to optimize. Anomaly and fault detection is another major class of problems that we deal with. Especially when you look at our customers who are operating in harsh environments, oil and gas, for example. There are pumps that are running, and it's extremely hard and costly to replace them. So detecting anomalies there is key. We have worked with customers in Canada, running oil wells, and then trying to identify anomalies, before they happen. And this is actually the interesting thing is this is an unsupervised model that we have to do because it's very hard to get proper labels and try to detect anomalies. Virtual sensors is another interesting area because we work with customers where it is very hard to have physical sensors, do some detections. So how do I predict, for example, it could be a glass plant that makes glass at very high temperature and we cannot put probes to detect temperatures with sufficient accuracy. So we have to use other indirect methods to detect the temperature. So we call it virtual sensors. And computer vision is obviously in the quality control area is a big one for us. We have lots of customers who rely on us, but this is an area that we are exploring. We have others like Cognex here who focuses exclusively on computer vision, but it's an area of interest. Now, things that are not shown here that are also interesting to us is in NLP. We have lots of textual data in many places that comes that we have to manage. So the question was among the use cases that we have, the one where we had most success, right? So I'll actually talk about a couple. One is in predicting the useful life of assets. So we have assets that are in the field. I'm talking about like large transformers or big circuit breakers, and it is important for us to predict the useful life so we can perform maintenance on them. So we've had pretty good success in using the data, and this is actually the one that I wanted to talk about because this is not purely a data science problem. There is also physics-based modeling that we have to think about. The second case is it's more for our internal use, which is about managing our customer support cases using text analytics. We've done a lot, and we can do with great amount of accuracy, detecting the type of cases and putting in the right queue to shorten the response time to our customers. Yeah.
Thank you.
Yeah.
Can you talk more about the virtual sensors? I've never heard of that concept, and so can you just maybe give a little bit more details about it?
Yeah, sure. So virtual sensors, let me give an example. So in oil wells, you want to detect the rate of flow, right? That is coming. And you can put a, actual flow sensor, inside the, pipe, so to speak, to measure the flow. And in many cases, it's impossible to do because either they fail too frequently because of the operating conditions, or they are too costly because they fail and then you have to go replace them, and many times you'll have to shut down pumping there to do that. So what we do is you can think of it as simply it's a prediction problem that what is the flow, but what we model it as a virtual sensor which is based on several other parameters that we can measure. So we have got sensors that can measure the data, but then we treat this as a virtual sensor. So what we did is we have a model that is built, that is configurable, parameterizable to various conditions. So it's actually a technical component. We call it virtual sensor.
So you infer via learned parameters on each one.
Yeah. Okay. Yeah.
This question is for building energy management systems, and specifically the interpretability of AI ML models. A huge challenge for building energy management system is the actual building engineers, and whether they pay attention to the existing HVAC management systems and whether they understand what it's telling them. And so can you is there a way for these AI ML models to enhance interpretability and make these building engineers' lives easier, or is that the same problem?
Yeah. Okay. So, I don't have to repeat the question. So I will try to address the question with a very specific scenario, right? To make the interpretability and make the life easier. So alarm management is a big problem in the buildings. Okay, so you have lots of sensors, and and we have building management systems, and there are alarms that come. Most of the times, the alarms are very cascading. Something happens on one end, then results in another alarm, that results in another one. And in the morning, someone will have 1,000 alarms to deal with. So we have not solved the problem. This is a problem we are working on, where we would like to infer the relationship between these alarms, so you can actually filter down to the root cause to simplify the life of a building engineer. So this is one area that we think there is more of the improving the experience of building engineers. Now, on the topic of interpretability, this is a key area of focus for us. It's very, if you have black box models that simply give with good accuracy, and we think they work, and we are dealing with equipment that has lots of physical characteristics. We produce UPSs. We've got battery aging models that we would like to improve, right? And without understanding physics, it's very hard, which means that these are interpretable models. Does that answer your question, at least tangentially? Yeah. I don't know if there was a question, or we are going back. Okay, so maybe I can try to. Okay, no, not that one. I think I went too far ahead. Is there a way to go back?
There's a little back. I think it's like the red.
Okay. All right. Okay, this is the one that I want to talk about, and I have 3 more minutes left. So let me go quickly so as not to jeopardize others' time. So I think if I look at, there are the use cases, but then I talked about, the doing things at scale. That is, real practitioner's problem. In fact, the first and foremost problem that we have is that of use case identification. From a 30,000-foot view, everything looks great. Problem is something that we have to work with. You dig down deeper, and then you really have to think about, is this an AI problem, or is this really a system integration problem, right? And this is this requires people who really can bridge the gap between AI understanding and the business world. So we call them AI product managers, in our teams. So really, the focus is to define problems that, first of all, identify problems that can be solved by AI, and then define them with sufficient precision that we can take it into actual exploration, incubation, building, etc. The second one is data. I won't belabor this. I think most of you, here know. But I will tell you one real challenge, in a large company and doing things at scale. We have to have business going, right? And having that everything data is going to be unified in a giant platform that we can all work with is a great idea, but never happens. We've got to work really hard with the data that we have and try to find the produce the models that work. The other topic that I said is the physics-based modeling. So this is key for us. We just don't want any black box models that seem to work and no one knows what they are. We just cannot deal with them. And it's a company of engineers, and we want to understand what's happening. The last one is AI ops. So this is a big topic because in a large company there are always pockets of innovation. People want to do different things, and there are providers. I don't know if you have AWS and Microsoft people here. You've got clouds that make it super easy, but it makes our life hard because everyone wants to build it, but we have to really manage it through the full life cycle. So we are building a really robust platform and practices around AI ops to really scale things and make sure that we don't have these zombie AI models that are running around. Lastly, education and culture. Industrial situations are different than digital-first companies. We have people who have been around in this domain for 30 years, 40 years, their entire careers, and we really have to educate, bring people thinking in terms of AI and data, and not the way we were doing things before. It's really to upgrade our thinking with modern technologies. I will stop here so as not to take time, and if you go to the next, okay, that's me. We really believe, and we have a strong conviction and commitment from management, in investing in AI. which is one of the reasons I'm here. And we see the transformative potential that this technology has. And we are, if I can put a little plug, we are building large teams in AI. We are based in Boston. If people are interested in partnering with us, just as we are doing with you, Bruce, would be happy to chat. And thank you very much.